So let's think about this terminology they sometimes use. They use the term angle of elevation, as you can see there, and the term angle of depression. And it seems like key thing to understand this angle of elevation, angle of depression, is actually focusing on what the horizontal line is. When they're talking about this observation and angle, and they're using this term elevation and depression, what you have to identify is that the horizontal line. Where is the horizontal line of sight? Then it's easy to identify. Okay? So that's, from my experience, that seems like the key. Okay, that's that. Sometimes they give you a picture because words sometimes not enough, and sometimes they just give you, paragraphs and expect you to be able to come up with the pictures like this. Right? So we'll see how it goes today. All right, here's our first word problem. Giant. Well, you have to you don't be too realistic and practical. Just try to simplify the situation as possible. A giant redwood tree casts a shadow of 532 feet long. There it is. We will underline that probably. Yeah, right? Okay, there's no number. Find the height of the tree if the angle of elevation of the sun is 25.7 degree. What is 25.7 degree? There's an angle of elevation of the sun. Okay? So this time I'm going to draw a picture. I have taught this several times, so it's very difficult to pretend that I'm doing this for the first time. But you will have opportunity to think about it next for other exercise problems. So here's ground, and I'm going to sketch a giant tree like this, and assuming this is kind of perfectly perpendicular, right? So let's see if I can erase all that. So maybe it is like this. I think it's better, more perpendicular, assuming that the center line is a perpendicular. So there's the giant red tree, and shadow of 532 feet long. So I'm going to use maybe blue one. See the shadow in here? Something like that. Let's say that ends there, and that is 532. Is that right? That's the information. And then angle of elevation of the sun is 25.7 degree. Okay? When they talk about elevation and depression, what is that you have to identify? Yeah, horizontal line of sight. That's what you have to identify. So, would you agree that horizontal line of sight is parallel to this ground level? Right? Fair enough. If you're standing in here, looking at the sun, and that's the parallel line. That's 25.7 degrees. So, even the guy is actually probably watching that. Let me say that the sun is coming in this direction, right? Parallel everywhere on the surface, local surface. And where is that 25.7 degree? Right. So this is horizontal line, right? So going up or down? Of course, going up. Elevation, right? So it's going up. That is 25.7 degree. That's what you have to identify. Right? All right. What has it got to do with this sun ray and the shadow? That was the earlier information. That is linked, right? The sun ray creates this shadow. So do you see that? That guy right there. And this is the key thing, right? You have to come up with this. That is the parallel line, right? Once you set up, it's a mechanical thing, and this is probably, if it was difficult for someone, and this is probably the part. Alright, this imaginary line in here must be what degree? 25.7 degree. That's the key there. Now you have an idea on how to calculate that height of the tree, right? Because we see some right triangle, correct? So with this picture, better be drawn briefly if this is a test problem, right? And that's what I mean by communication skill. And here, a little bit of additional drawing skill added there. But it's a way to organize information there. So why don't I make all that picture? It's not given, so you draw that. And from here, I'm going to turn this one into exercise. Go ahead and compute the height of this tree. All right. So I resketched the triangle here, and it involves opposite and adjacent, so I consider tangent. Okay. And again, after you set up this tangent equation like this, and I waited until to this stage before we actually turn this thing to numbers. I think that's a better way. It's my way of looking at it. Algebra is always helping whenever things get more complicated and lengthy. Any question about this problem? Is that right? Right. Good. So, but let's start together. See if there's any question that you might have. Just understanding what this is saying. From a point on the ground, 500 feet from the base of a building. So here's the flat ground here, and here's a building. Simplest building, not complicated building. And here's some windows. And 500 feet on the ground from the base of the building. And here's the base of the building, and here's the 500 feet. That's the point. Is that reasonable? No. An observer finds that, and that's where the observer is. So here's a stickman in here. That angle of elevation to the top of the building is a 24 degree. All right, elevation angle to the top of the building is 24 degrees. So you see that 24 degree from where to where? Yeah. So do you see the horizontal line? The guy's here looking to that, and this is the horizontal line right there, right? Angle of elevation is looking to that, and that's the angle. Okay. So at this stage, we're considering the height of this guy in here, right? But as far as I know, the book kind of ignores that, but it's unclear in here. But let's look at, continue reading that. That angle of elevation to the top of the flagpole atop the building is 27 degree. So let's say that was, find the height of the building and the length of the flagpole. That's the question. So do you think the height of the guy, the observers, that matters? This is the point of observation, and he's looking up, right? And we're going to calculate whatever is above the horizontal side of line, right? And whatever you get has to be added by the height of this guy from the eye, right? But that information is not given. So do you see that is incomplete in that sense? Whatever you do above that's the information they gave us. So we can calculate that above the, side of eyesight, but below we don't know, and it completely depends on how tall this guy is, right? So I have to, if I put this one in the test, I have to assume I'm going to put that, ignore this guy's side. He's just kind of lying down on the ground as you're looking above. That would be the situation. All right. So I'm totally ignoring this guy's height, and the eye is right here, right? And then making this up to the top of this building. So I want you to read this question. And what was the angle again here? 24, right? 24 degree is that. And do you see the horizontal horizontal line of sight? What did I do? That's the same as the ground level in this case, because we ignored that. And what is this 27 about? Flagpole. It doesn't say it is here or there, so I'm assuming the simplest possible. Here's a flagpole, and North Korean flag Yeah, something like that, whatever it is. So here's a like that, and then that's line of sight, right? And what is 27? This is not 27. From the horizontal line to all the way, that's 27, right? So let me use that different color. So from here to that is a 27. Make sense? So that's the situation. So we analyze, make sense out of it, and try to make the situation as simple as possible, just like putting the height of this guy at 0, right? So I think we can do from here, right? So let's do rest the part exercise. Exercise is to compute both heights. All right? Well, the idea is that you look at the big right triangle, and that's the difference between these two heights, right? All the way to the up and all the way to the top of the building. So I call the length of flagpole L, and I wrote it here, not just thinking about it. That's how it goes. I just did it in my head. Just write things down a little bit. Here's a nice way to communicate with the reader that what you're thinking, right? Label things that you're thinking about and write down the algebra that you were, simple algebra you were doing in here. That's this star part. Little l is a capital H minus little h, height of the building. All right? Any question about this problem? Cool? All right, let's do, all right. So let me know if I'll just read it for you. A plane is flying within sight of a gateway arch in St. Louis, Missouri, at an angle of elevation of 35,000 feet. The pilot would like to estimate her distance from the gateway arch. She finds that the angle of depression to a point on the ground below the arch is 22 degrees. And what is the distance between the plane and the arch? And what is the distance between a point on the ground directly below the plane and the arch? So for part A, I got 93,431, roughly that. Okay. So the right triangle we're looking at here doesn't have any angle that is given. So we had to figure it out. This is total, this part in here together 90 degree. So I subtracted off from 90 degree to get 68 degree in there, right? So let me write that down. 90 degree minus 22, that's in here. That's going to give us this angle right there. That was 68. Is that right? So you could use a 68. But the other one is a 22. And I did that to give you the idea. This 22 here and that 22 is always the same. If you go across the parallel line, that angle is the same, always. So you didn't have to actually calculate that 68. If you knew that fact, here's a 22, that's going to be 22. Then you can calculate trigonometry of a 22 right away without going through the 68 and the subtraction in there. But if you would have used the 68, that's going to be the same answer, right? Any question about this one? Part A. This problem is about drawing this picture correctly from that and then do a little bit of complementary angle trig and things like that. Is that all right? Good. So let's look at this. Is another exercise. You remember that bicycle, two sprockets and wheel things, right? That problem, after you practice a couple times, you realize all he's doing is multiplying it here and multiplying it there. There's my answer. That shortcut to answer that is short. But if you do that, I'm going to be extremely unhappy, right? In the test, you have to write down the thought process of all that procedure, right? Not just an algorithm. It's the same thing. Once we go through this problem, all that it's doing is just do this, formula at the end. That's what I'm going to do if I see this, silly cloud cover problem. But you really have to go through the procedure, and that's the problem-solving procedure and you have experienced this thought process to getting into that and things like that. Is that right? So let's look at this problem. They gave you the picture, so that's great. The measure of the height of the cloud cover at an airport. A worker shines a spotlight upward at an angle 75, and this guy's here, and that's, you can see that the spot in the cloud cover there. From the horizontal, an observer 600 meters away, and here, looking at that and communicating that that's 45 from here, and then we can compute this height. Okay? That's our goal. Right, there's an advanced theory, and your tutor might give you that. This is how you do it, simple and easy, right? That's not my goal in this education. What I wanted to teach and what I want you to experience through is not the way to get the answer quick and easy without thinking about it. The very goal is to make you think about it, these details of a thought process, right? So, and it is also stated in that acknowledgement statement and policy, you can't use advanced theorem at this stage. Is that all right? So all it counts in here is your thought process, and that's a challenging part. Okay, let's do this together. I'm going to label this point A, B, and C. All right, how many right triangles are you looking at? 2 right triangles, and they are sharing one of the sides there, right? And together we have some information in there. So I'm going to look at separately this triangle here. What do you think the label of this triangle is? A and C here, right? And I have to call that one D, so that's going to be D. That's our right triangle, right? I'm going to label the sides. 40. Here is already H, and that's what we are calculating. 600 meters given, and this is a part of it, right? So I'm going to label that X. We don't know what that is, but that's a part of 600. That's what I'm labeling. I'm not labeling AC. Probably we don't need it. If we need it, and we're going to label it later. But I'm labeling only X because 600 meters is a part of the information, right? So let's do another triangle. Down here is a D, and up there is a still common C. That's point B, and that angle here is a 75, which is not special angle, right? 45 is a special angle. So don't think that, you see 45, 45 here, and H is the same. So why would you label an X? Think about the situation. This is 35 degree, right? Then you would put an X here. So I'm doing a little general approach. Is that okay? So let's think that. And how about this one in here? What is the length of this thing? Unknown, but it's labeled H. That's the same segment, right? And what are you going to label in here? This one or that one? Bottom one, right? Why? Because it's a part of 600 meters. Correct? Now this X and Y has some relationship, right? We're going to write that down. What is it? X plus Y is equal to 600 meters. So that's something that we're going to need, and how is this related? There are various different approaches to this problem. This is only one way. If you can correctly do algebraically, if you don't like this XY thing, it's okay, but it has to be done algebraically and correctly. All right? This is one way. Okay, next thing is that use this equation in here. This has 2 variables in that, right? It's going to be an equation only in H. That's the roughly outline. So you relate H and X, H and Y, and replace that X and Y with H. Okay? So if that doesn't make sense, let's just take a look at the next spot. X and Y equation in here, we want to relate H and X and H and Y so that we're going to do something about this one in terms of H. That's better, right? How is H and X related? Through a trigonometric ratio. What is it? Tangent 45. Is that right? Tangent 45. Again, assume that we don't know. Is this like tangent 25? We have no idea what that is. Then what is tangent 45? H over x. Is that right? Okay. How about the other one? Same idea. Tangent 75 is h over y, right? Okay. So using the calculator, we have control on tangent 45 and tangent 75, right? But my style is we're going to leave it at that, right? We're going to turn it into number at the last stage. So you have two choices. Do you want to solve this thing for h? Do you want to solve this thing for x? Which one would you want to do? Hint is that you look at it here. This, we're going to return to this guy, right? We want to do something about x. You want to solve this one for x or h? X, right? Yeah. So let's do that. What is it? X times tangent 45, correct? Is equal to h. Then what is x? H divided by tangent 45, correct? Now tangent 45 is a number eventually. So x is now written in only in terms of h. That's good. And then if you stick it in there, that's right. What about next one? You see the similar pattern, and can we skip the algebra? So you solve for what? Y this time, right? Y. What is y? H divided by tangent 75, right? Right. Now think about why we solved this thing for x and y. That'll help you to do the next step. You did it, and what is the next step? Okay. So we solved this for x and y so that we return to this one, right? So let's do that. So what is it? That x plus y equals 600 now implies x is now h divided by tangent 45. And what is y? H divided by tangent 75. That is supposed to be a 600, right? That's the algebra. Now, if you can isolate h, that's the answer, right? Okay. Some student have a suggestion. I don't like that tangent 45 in the denominator, and then we have a wonderful way to turn that into something else. What is it? Reciprocal of tangent, right? What is it? Cotangent? Then it's going to be h times the cotangent. But I'd like to leave it this way, right? So here, what are you going to do? You factor out h. That's one way to isolate it. So is that all right if I factor out h like this? 600. Okay. That is 1 over tangent 45 degree plus 1 over tangent 75 degree. Is that all right? That's great. I'm just going to calculate that bulky expression to number, and that's going to divide 600, right? But it's my talent that making things a lot more complicated than is necessary. So that's what I'm going to do. But what you're going to do is that you're going to turn this one into a number, right? And then divide it by 600. And you get an answer in there. But I'll do a little bit more algebra to keep that 45 and 75 there, never touch it, and show the final shape. From there, you will see if this two information is different, 25 and 85, then you know what to do. Just replacing 45 and 75 to a different angle. All right? So from here is unnecessary part. Okay. So here's common denominator. Do you know how to put this in the common denominator? Product of these two things. So it's a tangent 45 times the tangent 75. Okay. So what is the numerator? This one, there's no tangent 75, right? So you have to multiply tangent 75 and tangent 75. So the first term will pick up additional tangent 75. See that? This one, the denominator tangent 75, so multiply tangent 45 here, tangent 45 there. So additional tangent 45 shows up in the numerator. If you combine this one algebraically, and this is the one expression, that is h multiplied there, 600. Correct? All right, so let's do that. So when you're actually doing this problem in the test, you're going to have some decimal right in front of you here, right? But here I have this better expression. Then what is h? 600 multiplied by reciprocal of this guy, right? Reciprocal of this guy. So reciprocal goes like this. Tangent 45 times tangent 75 divided by tangent 75 plus tangent 45. There. You know where the 600 come from, right? Anybody remember 600? That's the distance between the two observers. And you know where the 45 and the 75 come from, right? Yeah, in the next month at some point, if these guys to communicate, have a different information, then you know what to do. Just replace those three numbers. Boom, you have a height of a cloud cover, right? So that gives you general formula. And my warning was that you're not going to remember this formula and just plug it in here, and then that's not what's going to happen. You do this. That's a problem-solving skill, right? This thought process is what it's called problem skill, not just using some formula and juggling here and here's the answer. That's not mathematics. All right. Any question about this problem? Oh, by the way, what is the number? Anybody work this one out for me already? This is roughly 75 degrees. That is probably wrong, right? If it's more than 65, that means you probably lost the parenthesis down there or something like that. I guess the answer is 473 feet, roughly. Anybody second this? All right, here's the problem. This time again, I'll give you some time to read and attempt on your own to figure out the situation. And then I'm going to draw some additional diagram. You can check your thought process with me. Juggling of the algebra here. Okay. So let's go through it. How about this part? Sine of 60, that theta, is r divided by r plus 600. That came from the right triangle we looked at, right? And we have to isolate, we have to collect terms in that has r in it. And you can't quite simplify this one. If it is upside a different way, r plus 600 divided by r is a single term in the denominator, and then you can split it and simplify it. But if there's an addition in the denominator, you can't simplify any further. So you multiply that to the left-hand side. Okay? So you have r plus 600 multiplied in there, and because of the parentheses, you have to distribute it here. That one is multiplied to r that appeared in this bracket blue one, and that one also had to multiply 600. It has to be distributed because of the parentheses. So that's there. Then these are the two terms that has r in it. You collect them. So I collect on the right hand side, and knowing that it's going to happen in that form, so this is a negative number. However you do it, the final answer must be the same, right? So I factor out r just like the h was factored out. Then invisible 1 there, and sine theta remains. And left-hand side is just a number, you knowing that theta is that. So you divide both sides by this factor 1 minus sine theta, and then here, that's the final formulation. If you plug it in there. Okay? Then that's the number. Well, we know the answer. Anybody remember the rough answer to the radius of the Earth? I think it was 3,980 some miles from Google, if I remember. Probably this is a little bit more accurate than the Greek solution. Good? Yeah, that requires a little bit of algebra. Right? It's a good example that algebra is quite showing the power of handling this information. Any question? This right